You are literally bleeding marks on data integrity questions right now, and it's not because you don't know the theory. It's because you aren't using the exact specific words the Cambridge examiner is hunting for. In this explainer, we're unlocking the 0478 mark magnet strategy for checksums and check digits. We're going to see exactly how top-tier Cambridge students extract every single possible mark from the examiner, starting right now.
Check out this typical student answer. A check digit checks if data is correct. I mean, it sounds totally reasonable, right? But here is the painful reality. That response scores an absolute 0. Nothing. Now compare that to a top-band mark magnet response. A check digit is calculated from barcode data, appended, and recalculated at the point-of-sales terminal to detect data entry errors. See the difference? That is the harsh reality of IGCSE computer science. Knowing the general vibe of the concept just doesn't cut it. You need absolute algorithmic precision.
0. That is exactly what generic definitions without any context will get you on your 0478 exam. Writing down some short label or a vague, isolated fact, it instantly tanks your grade boundaries. The examiner is literally sitting there with a mark scheme that absolutely demands specific, process-driven terminology. If it's not there, they can't give you the mark.
So let's talk about why ordinary standard revision fails so spectacularly in this subject. If you're just relying on rote memorization, you're walking straight into a trap. You end up with vague wording, you skip absolutely crucial process steps, you completely ignore the specific digital scenario they gave you, or worse, you confuse similar concepts. Examiners don't want a dictionary. They demand context-anchored scientific reasoning. They want proof you actually understand the mechanics of the process.
And this is exactly where those precious marks just bleed away. Your theoretical foundations for checksums and check digits rely heavily on knowing the difference between really close nearby concepts. A massive mistake learners make is completely blurring the lines between validation and verification, or memory and storage. If you mix these up during your data checks, the examiner literally cannot award you the marks, even if they know deep down what you were trying to say.
Let's secure our very first quick win right now by firmly establishing the technical reality of what these two error checking methods actually do. A checksum? That's a calculated value used to test data integrity specifically during data transmission over a network. But a check digit is an extra digit appended to a number, like a barcode, to detect data entry errors made by a human or a scanner. They are two totally different tools built for two totally different digital environments.
Now, in just a moment, I am going to show you the exact examiner clue that changes your exam answer completely. It's a total game changer. But to even spot that clue, you first need the framework that makes it incredibly obvious. Without a rock-solid, structured way to recall this stuff, it's way too easy to just freeze up when the exam pressure hits.
Enter the 4-prompt answer framework. This is your ultra-reliable memory structure that practically guarantees you hit every single mark scheme requirement. Every time you face a checksum or check digit question, you've got to ask yourself 4 things. 1. What is it? 2. How does it work? 3. Where is it used? And 4. Why is it better or worse than the alternative in this specific situation? If you can answer these 4 prompts out loud, you are fully locked, loaded, and ready for exam deployment.
When we actually apply this framework, it builds into a flawless Cambridge-style process sequence. The technical methodology here has to follow a super strict, disciplined path. First, the concept. It's a checksum. Next, the process. You absolutely must state that a value is calculated from the block of data, transmitted alongside the data, recalculated by the receiving computer using the exact same algorithm, and finally compared to the original checksum. And then the evidence. If it matches, the data is accepted. If not, an error is flagged and a resend is requested. You have to explain this exact algorithmic structure so clearly that anyone reading it could follow it step by step. All right, now we are escalating the stakes, because examiner-style performance depends entirely on specificity. Generic copy-paste responses are a fast track to nowhere. You must anchor your technical explanation strictly within the specific digital scenario that the question provides. Whether they're asking about a school attendance network, a banking system, retail point-of-sale barcodes, robotics communication, or embedded systems, your answer has to actually live inside that specific world. Let's put this to the test with an interactive challenge. Here is a super flawed scenario-based student answer about a retail barcode system. The student wrote, "A retail store uses barcodes. The system uses a check digit. It finds the error if the cashier types the barcode wrong." Okay, pause and predict for a second. Think about that answer again. What fatal, completely missing process steps just cost this student 2 massive marks? I mean, they correctly identified the method and they got the scenario, but they completely skipped the actual mechanics. Well, here is your examiner-style correction. That flawed answer merely named the method but totally glossed over the actual process. To secure top-band computational reasoning, the correct answer has to state, the point-of-sale system recalculates the check digit using the entered digits and compares it to the originally appended digit. Do you hear those verbs? Recalculates, compares. Those right there, those are your mark magnets.
So the absolutely crucial takeaway here is this. Anchor everything to the context. The exact words that pull marks are always the ones that connect the theory directly back to the provided hardware or software scenario. Students often know the theory beautifully, but they still bleed marks because they just forget to explicitly mention the point-of-sale terminal or the barcode scanner that was sitting right there in the question prompt.
Real-world transfer matters big time. To make sure this knowledge actually transfers perfectly into some unpredictable wild exam question, you need a 3-pass revision cycle. Pass 1, secure your key definitions and contrasts. Pass 2, rehearse those worked explanations out loud, detailing every step of the process. And Pass 3, actively change the scenario and adapt your explanation. Try applying it to a robotic arm and then maybe to a secure banking transfer. Do this and watch your exam adaptability absolutely skyrocket.
Okay, time for a rapid-fire challenge. Here is another classic wrong turn. A student writes, the checksum matched, so the data is completely secure and hasn't been hacked. Can you spot the fundamental theoretical error going on here?
The fundamental error here is completely confusing data integrity with data security. Checksums are a tool for data integrity. That means they detect accidental changes, like a flipped bit during transmission because of some random interference. They are definitely not a tool for data security. They do not prevent malicious changes by hackers or malware. Think about it. A hacker could easily alter the data and just attach a brand new, freshly calculated checksum. Nailing this contrast is an absolute mark magnet for sure.
So we've totally mastered the process explanation. We know the steps, we know the contexts, and we definitely know the difference between integrity and security. But what happens when the 0478 exam doesn't just ask you to explain or describe, but instead hits you with the absolute highest difficulty command word, evaluate?
This is exactly where the ceiling gets raised and those A-star grades are actually secured. You cannot just use the same simple explanation framework for an evaluation question. You have to weigh advantages against disadvantages, and you have to justify your design decisions based on a highly specific scenario. Learning how to conquer these high-tier questions is your absolute mandatory next step, because a whole lot more mark magnets are waiting for you.
You now have the framework to secure top marks in explanation questions. But evaluation questions are an entirely different beast altogether. They demand you weigh advantages against disadvantages in really complex, real-world scenarios. So ask yourself, next time you face an unpredictable digital scenario on your exam, are you just going to recite a memorized definition, or will you command the logic required to evaluate it like a true computer scientist? Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations.